Hello, Terraforming Mars fans. I'm Kevin, and I'm here to show you a project that I'm working on called Solarnet. And I'll warn you up front, if you are not already a pretty decent fan of the game Terraforming Mars, you will almost certainly find this video incomprehensible. So I wouldn't recommend it. Also, I think this first video that I'm making might be a little more digestible by people who already have a software background. That might make it a little easier to understand. I'm hoping to record, future videos that do a better job of explaining things. But, and in general, I'm hoping to record, better and better versions of this. So please check the YouTube description to see if I'm already linking to a better version of this, and please go there. So what is Solarnet? Besides my life, Solarnet is a toy program I'm working on that's related to the game Terraforming Mars. I think I already gave the disclaimer about how you need to know the game pretty well already, and really this won't appeal to everybody. This will only appeal to a very particular kind of very geeky person like myself. Anyway, what is it? All right. SolarNet is a game engine for Terraforming Mars. Okay, what is a game engine? A game engine, as I have, conceived it and how I've built this thing, is a standalone software library whose job is to manage game state. Obviously, and now I'm going to have to go into what is game state. You could probably guess, but I'm going to try to give it a more precise definition if I can. Game state is the complete information about a game in progress that tells you everything you need to know in order to reconstruct that exact game in another time or place and resume the game. And ideally, it contains only that information. So if you imagine you're playing the game with some friends on the table and you suddenly realize that you need to get up and go to lunch and the cat is going to wreck everything while you're gone, you would need to have some way of recording everything that's important. And many things aren't important. Like, it doesn't matter if one tile is sitting a little bit off of the hexagon that it's supposed to go on, like it's a little bit crooked. It doesn't matter. It doesn't even matter if I'm playing green and you're playing blue, or if you're playing blue and I'm playing green. So those things aren't really part of the game state. Most of the game state you can think of as just putting a camera above the board and taking a picture. That will tell you most of what you need to know. And the elements are really what components are involved and where are those components. And where really means, in a board game, how do they relate to other components? And so really all the components that make up a game state form a graph structure where usually an edge in the graph means this is physically resting on this other object, or this is sitting in this location. So you would need more than that photo. For example, you wouldn't remember whose turn it was. You wouldn't remember whether they were on their first or second action. There's a lot of things you wouldn't know. We'll get to that later. I can go into more detail about a game state, but we're really trying to get back to what the engine is. A game engine is a software library that manages that game state, by which I mean, for some game state, some initial game state in a moment in time, and some decision that a player is trying to make, the engine calculates the game state that should result from that, or it decides that that choice was not a legal choice in the first place. That's really all the engine does. It's like to write it in pseudo, well, I guess that is technically Java syntax. It takes in a game state and a player choice, and it spits out the game state that results from that, or it says you can't do that. Now, that exact signature is not in my project, but that's a conceptual picture of it. The key thing to understand is that that is all the game engine does. Its only job is to know the rules of the game and understand exactly what should happen in any situation. It is like, you could think of it as like a giant Texas Instruments, calculator that just calculates scenarios for you. It's a very low level. You would never really want to play a game interacting directly with an engine. And in fact, You would not even just write a user interface and have it talk directly to a game engine either. It's very, very low level. You would want to have a middle layer that sort of translates the abstract language of the engine into more player-oriented concepts and terms. So I'm trying to make a game engine for Terraforming Mars. The reasons why I'm doing this, first of all, there is already an open source app for playing Terraforming Mars. It is excellent. It gets the rules, I'm going to say 99.99% correct, which is down to a lot of hard work by those developers. I play it daily. I love it. There's no need to replace anything that they've done. The real reasons why I'm doing this are simply that it's fun. It's hard. It's actually very hard for me. And I just love the game and I just love fiddling around with it. It may not ever have any practical use at all. And if you're somebody who could help out, but you need to only work on practical things, then you're probably not going to want to come near this. But it is a working game engine, and you could, if you were going to train like an AI player, it might be an appropriate API to train that player against. So my ambitious idea in making this engine that is different from anything else someone has tried before is, what if you did not have to actually write like computer programming code for each card, but you had a way of expressing each card as pure data, even the full instructions of the card, everything there is to know about a card, just as information. And here's what that might look like. For the most part, there's nothing surprising here. This is just a JSON block, and it provides some fields of information, the card's ID, the fact that it belongs to the base bundle and not the Venus bundle. It's a project, it's an event, it costs 14. But in order to express what the card does, the card's behavior, this 2 Terraform rating that you see here is actually expressed in a custom language that I designed for this project. When all you're doing is gaining 2 Terraform rating, the language is not super impressive. That looks pretty simple, but we're gonna move on here. It is a specification language. That means it is not a programming language. There are no variables. There are no loops. There are no statements. It is not what you think of as a programming language that says do this, then do that, or even a functional language that builds everything out of functions. It is just a specification language, which means it's a way of saying what a card does that is precise. Then the engine is written in it's actually written in a language called Kotlin that you may or may not know. The engine reads that specification and then it decides how to actually run the card. So I'm going to spend a while going through some pets features here. If you really want to skip to the demo, you can do that. But a number of things in the demo are going to be very mystifying if you don't have a basic understanding of the language first. So here we go. Here's another card, and this is the last time I'm going to show the whole JSON block of data here because most of it is uninteresting. You've got tags, you've got cost, you've got the fact that this is an automated card. If the card had a requirement, that would be in here. If it had a resource type that it can hold, that would be in here. But the interesting parts are going to be inside the sections called immediate, effects, and actions. Actually, the requirement is fairly interesting too, but whatever. These are the parts that are in the bright white color that are written in the pets language, and that's what it looks like. So this immediate effect on this card is represented as a prod block, where inside the prod block is 2 titanium. Okay. No big surprise here. Guess what? You can use minus signs in the language too. Isn't that amazing? You can have minus plant and +4. This does not need to say a lot about how to handle that because it expresses what's different about this card from every other card, and then the engine can take over from there. We can even use X instead of numbers. That basically works. We have actions. Actions are depicted with a minus sign and a greater than sign. Just like that. That is how this card is represented. And of course, you can connect things with the word or. On the cards, they usually use the word or, but sometimes they use the slash, which is kind of weird because slash usually means per, but whatever. We're not picky. Here is a case where the card is telling you not only to add a city tile, but it's telling you where to put it. So when the engine starts up a new game, it has a number of these areas that it considers to be components that already exist. There's 61 Mars areas that make up the Mars map, and there's a couple of remote areas, such as Ganymede Colony area. And this is how you write an instruction that says you must put the city tile on that area. Now, why it looks like that with the angle brackets, we're going to get into shortly. Another thing to look at here is that I wrote this slide incorrectly. That's another thing to look at. 1 victory point. Actually, I don't need to say the number 1. You can just say victory point per Jovian tag. That is what the card really looks like. And so when it's time for the end game, this signal goes out called end, and it prompts all the cards that have an effect like this to start spewing out the victory points that you earned. So in this phrase here, city tile of Ganymede Colony area, the words or the camel case names that you see here, there's 2 of them. Those are class names. And the whole thing together is a type. So there is a type system defined for this thing. There is a class loader and all of that stuff. And we're going to see like kind of a few features of the type system as we go here, but it gets a little bit, some of it should be saved for an advanced session. There is a subclass hierarchy, as you might imagine. Obviously, a city tile is one kind of tile, but there are other kinds of tiles as well. In fact, city tile extends owned tile, which extends tile, which is useful because ocean tiles do not extend owned tile. They do not get a player cube on them, but they still extend tile. Ganymede Colony area extends remote area, which extends area. And the single root of the whole tree is called component. This entire tree is pretty large and intricate. Here is most of it right here for you. I'm not going to talk about all this, but now if you're a crazy person like me, you can pause it and examine it and see what you think of it. But I'm going to move on. The language that I defined borrows a lot of features directly from the icon grammar that is used on the published cards. And as you can see in this presentation, I'm using the images from the online open source app, but in terms of the icon grammar, they're virtually identical to what is really used on the printed cards, so it works. And one of the things that grammar does is it has a rule that says when you see a city tile, it means a city tile belonging to you, the owner of this card. If we meant any city tile, we would put a red outline around it. So I kept with that idea in the language. City tile by default means city tile of player 1. Incidentally, if you are player 1, you are a component. Let's go back to the picture. See that little green meeple up there? That's you. You are a component in the game. And that means that you can be depended on by a city tile. So here's what this actually looks like. First, we have the immediate effects. And immediate effects start with this colon. That means when this component is created, this card, hand out these rewards, 40 money and a city tile. The next line says, so the next line is the lower left effect that you see in the lower left of the card. A city tile played by anyone on a Mars area will give you 1 production. It gives you the 1 production because you own the card and it just said 1. It could also have written 1 mega credit, same thing. But in order to say like not just me, but anyone, you have to put the word anyone in there, as you see here. So this does a couple things. It says that the effect is general to anyone playing the city card, but it is restricted to only the Mars areas. And that matches it matches the words on the card, and it basically matches the iconography, except for that the icons had to use a little asterisk there, and we don't. And then the lower right effect is much simpler. It's a city tile by the owner of this card, triggers you to get 3 money. Very simple. So that's how the difference between red outline things and non-red outline things looks. This type that you see, if you're familiar with a language that has generic types, it may remind you of a generic type. That's because it is a generic type. It is a generic type system. It's a very simplified and streamlined and limited generic type system, which I'll have to really go into detail about some other time. If you're familiar with what it means for a generic type parameter to be covariant, I will mention that all type arguments in pets are always covariant. I will gloss over that otherwise. But a cool thing to understand is that this doesn't just represent only a generic type. It also represents an actual dependency. And what that means is you cannot have a city tile exist unless the player exists first that owns it and the Mars area exists first for it to go on. And any city tile in the game, you can ask it those things. It knows who it belongs to, and it knows which Mars area it goes on, or really which area it goes on. So that is very, very useful. Like I said, board games are generally, their components have this graph structure, and it often relates to like where the components are sitting physically. The idea, we're going to go through some examples of dependencies in a second here, but the idea that I want to get across is that the nature of the language is to have complex nouns but very simple verbs. In fact, there are kind of only 3 verbs in the whole language. Gain, which is expressed by just a noun. Remove, which is expressed by a minus sign and then a noun. And then count, which often usually comes after a slash, right? Those are basically the only verbs. I guess you could say the 4th verb is trigger on, like trigger this to happen when that other thing happens. Here are some examples of dependencies. Every tile must go on an area. Every owned thing must have an owner. That's pretty obvious, but owned is this abstract type near the top of the tree. Some of its subtypes, subclasses, are resource, production, card, terraform rating, victory point, milestone. And not all tiles go under here because ocean tiles don't. So this other abstract type called owned tile comes in under there. We also have a dependency from a card bound onto a card front. All that card bound is a way to group tags, card resources, and action used markers into one bucket so that I can just declare one dependency onto card front. I could also define 3 different ones, one from tag to card front, one from card recipient, but that's kind of a pain, so I didn't. And for some reason, I put tile to area again. That's probably because I meant to edit it to say something else. I forgot what that was. In this diagram that you didn't look at, you can see the dependencies drawn in as these dashed faint gray arrows. So those are the dependencies, and you can see their cardinalities. This is a pretty old diagram. I did it 2 years ago. It's not 100% current anymore, but whatever. So we explained that nouns are generic types, but they're actually more than that. They can also have embedded restrictions or filters, or call them requirements or predicates or queries, whatever you want to call them. So this card, in addition to the production that it does, it wants you to place a city tile. You have to place it on a land area, but it wants to be very specific about what kind of land area you can put it on. And so in the engine, the way I have it all configured, there's some code that says every time a tile is created, it creates these neighbor components. It creates basically, if you place a tile in the middle of the board, it creates 6 of these neighbor instances to represent the border between the tile and the empty space next to it. And so when we want to restrict where this city tile can be placed, we just say, well, we need it to be a land area that has 2 or more of these neighbor instances, meaning that it has 2 neighboring city tiles. And of course, by saying angle bracket anyone, that makes sure to count anyone's city tiles, because it does not have to be your own. So these incantations, where there's embedded parentheses inside angle brackets, they come up for tiles a lot. They are very head twisty. Like they will really twist your brain a little. Also, they don't work yet, so there's that. Anyway, moving on. When you write instructions that belong to a component, those instructions can refer to that component with the word this. So, for example, the first action on this card says just gain a floater. When you're gaining a floater, you'll get to gain any kind of floater you want. You'll be able to put that floater anywhere you want. But the second action says what you spend must be a floater on this. I could also write floater on aerial mappers of player 1 or whatever, but it's easier to just say this. Now, I will point out that with owners, we reversed it so that the owner, when you refer to something like a resource or a tile, it assumes you mean your own. The icon language used in the printed game does a similar thing with card resources. It says by default, we mean only a resource that goes here. And if we mean actually anything, they put an asterisk on it. So I really thought about mimicking that in the language as well. But some other time I can ramble on for 5 minutes about why I decided not to do that. There are things called metrics. Metrics are, they appear on instructions after a slash. Also awards. Each award owns a metric that makes that award different from other awards. And here is a, somewhat complex metric. They're usually just like 1 per microbe tag or whatever. This one has to do a little bit of math. It has to count the space tags of anyone and then subtract the space tags that belong to you. But that actually works. One of the objectives that I had in the engine is to homogenize everything as much as I possibly could. So every aspect, every kind of behavior in the game is implemented as a triggered effect. This is an example of that. You don't think of a discount as a triggered effect. You think of it as, well, it kind of modifies a game rule. But what we do instead is, when you're going to play a card that costs 15, we create 15 instances of this thing called ode. It's as if it's an object that you have on the table, but obviously you don't in real life. It creates 15 ode, and then it sends out a little signal called play tag of earth tag. And if you're doing 2 earth tags, it'll send out that signal twice. If you already have Earth Office in play, every time it sees that signal go by, it will remove 3 of your ode instances. And after it does that, you find that your 15 cost card, you only have 12 left. And then you can actually pay your mega credits to reduce it down to 0. As soon as they get down to 0, it actually plays the card for you. There'll be a lot more to say later about why we reduce everything down to a triggered effect in this way. But one thing that's nice about it, by really homogenizing and making uniform the way everything works, like this, it will make the log files from this engine very easy to analyze. So, for example, you can say, well, how much total money did Earth Office ever save me? And then you can just query all the total number of ode instances that were removed by this card. And that does what you want, because if you play a 2-cost card, you only want to sort of give Earth Office credit for saving you 2 money, because that's all it did. And in fact, it would only have removed 2 of the ode instances. It couldn't remove any more of them. So there'll be a lot more to say later about that sort of analyzability that I'm going for in the log files. Here's another kind of homogenization that it does. Every single component in the game, and really every kind of game state of any sort, is represented as a thing, as if it's a token that you set in front of you. So we don't have like a temperature meter that is set to -6. Instead, we say, well, 12 instances of this temperature step component have been created. As if there were just a pile where you kept adding a pile of tokens. You notice that, like, if you start at -30, and then 12 temperature steps would be raising it 24. From that, you would get to -6 degrees Celsius. So to us, that's just 12 things that exist in the game state. Your terraform rating is just that many things that exist in your game state, etc. That means that every single thing that happens to the components of the game, to the game state, is just adding a number of some kind of thing, removing a number of a thing, or sometimes transmuting a number of things directly into another kind of thing. But that's really all that can ever happen, and that makes managing the game state very easy. It makes rollbacks very easy, logging very easy, all kinds of stuff. Here's a card. I left off the temperature step part of it, but it wants you to place a lava flows tile onto a volcanic area. And, there are, on the Tharsis map, there are 4 areas that extend the type volcanic area. But this instruction, those of you who know the game well, know that this is not quite right. We can fix it, though, like this. So what this says is, you may place a lava tile on a volcanic area, or if no volcanic areas even exist, then you can place a lava tile, full stop, end of story, no restrictions. Lava tile all by itself means you can place it anywhere you want. So this actually works, because if you're playing with the Hellas map, there are no volcanic areas on it. And each game that you start, the things that you're not using in that game just don't even exist. The Tharsis map, none of it exists, of course. And so when it checks how many volcanic areas there are, it'll come up with 0. That means you satisfied the requirement for the right-hand side of this instruction, and you're good to go. I'm going to talk a little bit about one of the most interesting rules, or interesting mechanics in the sort of basic workings of the game. And that is this concept of reaching a dead end or having to roll back. So in the game, instructions are generally mandatory. You don't get to choose whether to do them or not. But you do get to choose what order you do them in. And sometimes you get to make choices about how to do them. Like if it's place a city tile, you get to choose where to place it, etc. But you're not allowed to make any choice that would cause the current action to dead end, that would make it so that there's no way for you to complete the action. So, for example, if the board was completely full of tiles, you cannot take the city standard project and pay 25 to gain 1 money production, which you might try to do if it got you the banker award. But you can't, because you would get the 1 production and then you would dead end. You would stall. You'd be like, I can't place this city tile. There's nowhere left for it. Actually, the board doesn't even need to be full. There just has to be no places that aren't already next to cities. So this is very interesting, but the engine just doesn't even worry about it. It lets you walk into a dead end. And if the game stalls, you will just have to roll that back. I mentioned that the way the library is set up, it makes rollbacks very simple. So it just says, hey, if you can't complete it, I assume you'll just have to roll back and start over. And, that's a way that you could think of the game rule to begin with. You could play it and you could just start doing stuff and then be like, I need to roll back. You just don't want to do that in real life, because you might have drawn a card and there's no way you can undraw a card. So I just mentioned that. Engine doesn't prevent dead ends. It just stalls out and makes you roll back. That turned out to be a very, very handy, what's it called? Very, very fortunate situation. It simplified a lot of things, a lot, because we can take advantage of that. Here's pets. Now, I mentioned that we want everything to be a triggered effect, and here's 2 of them. First of all, when the pets card comes into existence, which means when it gets played on the table, then, an animal is created on this, which is the pets card. So great, you get an animal. Also, when a city tile is played by anyone, you also get an animal on this. But there is something else on the card. Well, I left off the victory points. That's another thing. But there's something else besides that and the victory points. Animals may not be removed from this card. This turns out to be very easy to do, because we just write, remove an animal of this is our triggering event. And if that triggers, we have this thing that says die. All that die is a special component that the engine refuses to ever create. So if anyone removes one of these animals, their action will stall out. They'll never be able to complete it. They'll have this die instruction sitting on their queue. They can't go anywhere. They'll have to roll back. That's weird conceptually, but it made so many cards so much easier to take advantage of that kind of thing. That is the end of the slides that I have. That gives you some basics of the language. Now, let me show you some stuff, because I mentioned that the engine is only a library. That means all we can do is sort of write code that speaks to it. So I did wrap a really basic UI, command line UI around it. Very basic. What do we do here? Hold on a second. GitHub.com, Martian Zoo, Solarnet. And this kind of thing is called a REPL. You may have heard of it. Many languages have their own REPL. I made a REPL for this. It is very basic. It is not a UI that you would ever want to use to try to play the game. You would go mad. And let's start that going, actually. I called the REPL Regoplastics because I thought that was cute. That Regoplastics is like REPL. And at some point, I just decided to name everything that I do in this project after a card. Why not? This is going to be a very unexciting experience here. In fact, many things I do here, you'll be like, oh my God, why would you ever want to do that? And the answer is you wouldn't. You would have, software libraries that build layers around this to make it easier to use. So when we start out the little program here, we're in a mode that I like to call the green mode. Actually, I don't like to call it that. I just did call it that. It's called the green mode, all right? In green mode, it's like a sandbox kind of experience. It has created a game for us. It's created 2 players. Let's say we want to redo that, actually. And let's, instead of just base and the map, let's also add Prelude and Venus. And let's say there's 4 players. Okay? So now it created us a game with more stuff in it. Actually, yeah, okay, let's leave it at that. It's created all the basic stuff for us. If I type list, all these things exist. There are 67 areas. Why are there 67 areas? Because there's 61 on Mars. And then I included Venus. So there's 4 from Venus, 2 from the base game. What the heck's the other one? Maybe Prelude has one? I forget. But there's a total of 6. Actually, let's do this. Let's list area. Turns out there's 61 Mars areas and 6 remote areas. Let's list those. And then I just did the math wrong. That's all. There are just 6. For some reason, the areas are named by their IDs. I don't know why I did that. There's also let's see what's interesting here. There's one component called generation. Each time we move to the next generation, it just creates another one of those, and that's how you know what generation you're in. That's not too interesting. The real interesting thing about the green mode is it's just like this playground or sandbox where you can do whatever you want. So first of all, I'm going to become player 1, and I'm going to take off the backtick there. It's fine that happened because I can point out now, I can warn you that I've not spent a lot of time on the error handling, so a lot of times things just stack trace like that. And it will be very frustrating for you if you're new, I have to admit. So I became player 1, and now my prompt has changed to player 1 out of 2. That is interesting. When did I go back to the... when did I lose my game? Oh, that's interesting. I've got a bug. It should be telling me that... Okay, well, I got a bug. No big deal. Let's just make it more happy. In fact, you know what? I'm just going to restart it. I got lots of bugs. I didn't want to wait to do the demo until I had no bugs left. Here's the point. I'm going to become player 1. I'm going to spell it right. My prompt changes to player 1. And I'm going to say, you know what? I would like it if I had 666 money. Boom. It just gives it to me. That is what green mode is all about. But so it's about more than that. I can also say exec ocean tile on, let's say, Tharsis. I don't remember whether this is an ocean space or not, but it'll let me do it. It'll let me do whatever I want. This little log tells you everything that happened in response to that. It placed the ocean tile I asked it to. Then it gave me a terraform rating. And, who gave me the terraform rating? Well, the ocean tile is what gave it to me. And then why did it do it? Because 373, which if you look back at the thing here, 373 is the ID of this event right here. So every line tells you which player it is on behalf of, or the engine. The engine is also like an NPC that it could be for. It tells you which component owned the instruction that made it happen, and then it tells you which previous event triggered the thing to happen. And then also the Tharsis 5.5 area itself gave me 2 plants. How nice of it. It gave me 2 plants. That's very nice. If we look at our little map, you can see an ocean tile in the middle on 5.5, right where I put it. This map, by the way, not a function of the engine. It is something I wrote into this crappy little command line UI. Maybe that was obvious. Let's also give ourselves a greenery tile on Tharsis for, let's say 4.5. And now all kinds of stuff is going to happen. I think. Yeah. Okay. It gave me the greenery tile. It gave me 2 money. Actually, it's not that it gave me 2 money. It's that the ocean tile on Tharsis 5.5 gave me the 2 money. Then the greenery tile I played gives me an oxygen step. The oxygen step gives me a terraform rating. And then back to the Tharsis 4.5 area, remember that? It gives me 2 plants. All these things got triggered just by placing the greenery tile. But in this mode, the deal with this mode is I can initiate whatever I want, and then it handles the consequences of that. So we should play around with this a bit. What are some things we can do? So first of all, I gave myself 666 money, and then I got 2 more from placing next to the ocean. I can also give myself, let's say 5 money production, 4 steel production, 9 plant production, whatever. If you know a bit about the language, like from my slides, you can type in stuff here and see what it does. Here's an important thing about the engine as it exists right now. The engine doesn't currently keep track of who has what card. It knows how many cards you have. Like, let's say that I have 10 project cards. Okay, it will remember that. And if I look at my board, board doesn't tell you how many cards you have. But I can count project card, and it knows that I have 10 of them. And if I count project card of player 2, it knows that player 2 has 0 of them. So it knows that I have the cards in my hand, but it doesn't know what they are, and it doesn't care. If I tell it, hey, play Arctic Algae. In fact, let me just do this to be a little nicer. Lose 12 money and then play Arctic Algae. I didn't have to do that, but whatever. It's like, oh, okay, cool. You've got Arctic Algae. There you go. And now if I count my project cards, it knows that I have 1 fewer. But it works on honor system about what cards you have in your hand. The reason for that is that for a very long time, all I'm going to be doing with this engine is testing it by playing a real game somewhere else. I'll play a real game like over the table with my daughter or on the open source app. I'll play the game there, and then I'll log what I'm doing in here and make sure that this engine produces the same results. In order to do that, this works fine. This engine doesn't need to keep track of what cards are in what player's hand, because the real game, takes care of that. So that makes it easier. And then there's at least 20 or 30 cards that they are so much easier to do this way. I'll have to come back and do them a more difficult way later. But what's a good example here? Okay, what's the one that you spend a variable amount of energy to draw that many cards? It's funny, I can never think of the names of the cards. What's a good example of a thing that this makes really easy? Well, okay, Search for Life is outright comical. Search for life is absurd in how simple it is. What it says is, I know there's a lot of stuff here. You have to look at the, you know what? It's going to be easier if I say describe search of life of player one. This is still a big mess. This is a lot of computer ease here, but you will see, you know what? Go up and let's look at the raw effects. When you use the action on this card, ignore the word raw for now. You remove one money, and then you optionally take a science resource if you want one. That's it. It just believes you. I showed this to you without really explaining what you're going to see first. Sorry about that. The question mark refers to an optional instruction. The exclamation point is the default behavior, and it gets added for a mandatory instruction. But if I describe, like, I think it's maybe asteroid, no. Oh, asteroid card, I had to call it. Where you see that it removes 3 plants from anyone, it adds the question mark in that case, because removing resources from anyone with the red border is optional. It's kind of basically the only optional thing in the game, except for like Mars University and like flipping your pharmacy union. There's not many optional things, actually. There are things that like you must do if you can, and if you can't, then you're fine. But very little is like purely optional. Anyway, I'm rambling. What should we do next? I don't know. Let's look at our map. We've played Arctic algae, so it won't surprise you at all that when I place an ocean tile on, and again, I can put it anywhere. Let's put it on, I'm going to use the abbreviation M74. Is there even a 74? Yeah, I think there is. Great. You can see on the last line that 2 plants came to me, and Arctic algae is who gave them to me. So, and like I can type, I think it's log, and I can see everything that's happened. This little command line REPL makes it easy for you to roll back to any previous thing that you want to go back to. So I would just type, roll back. Let's roll all the way back to, let's see, I placed that to 447. And then it undoes that ocean tile. It's gone. And let's say that I give myself, this much money. And then if I want to undo that, okay, it's easy in this case because the number appears on the log line, but it also appears in the prompt for the line where I did it. Either way, sometimes one is easier than the other. I know to roll back to 447. Once you roll back, you can't roll forward again. All that stuff is forgotten. What else can we do? We can query things. Okay, so is it true that we has 2 ocean tile? This is a requirement like a card might have. What requires 2 ocean tiles? That thing that turns energy into oxygen. That thing requires 2 ocean tiles, and that didn't work for some reason. It's because of case sensitivity. A lot of things about this REPL are going to drive you mad. Everything's case sensitive. Deal with it. Sorry. 2 ocean tile as a requirement is false. Plain old ocean tile is true. Max 1 ocean tile is true. Screw that up. Oh man, this is going to be so annoying. The REPL commands are lowercase, but the actual pets language commands are uppercase. I will figure out what I want to do about that at some point. It's going to drive you nuts. What else can we do? We can run scripts that are stored in files, count things, list things. Okay, I know what I need to show. Okay, let's exec research outpost. Output. So it gives me the research outpost. It takes away a project card because I had to lose a card from my hand to play it. It gives me a science tag that is sitting on the research outpost card. It gives me a city tag that is on the research outpost card. And a building tag. Wow, there's 3 tags on that card. Okay. But it can't actually do the city tile because it doesn't know yet where I want to put it. All it knows is the instruction that it got from the card. The card told it has to go on a land area that has no neighbors. Okay? So this is basically, when you see these parenthesized expressions, it means that this whole type is abstract. It's an abstract type. And as you know from programming, like any programming language, you can count how many you have of an abstract type, but you cannot just create or remove something of an abstract type. You have to be more specific. So in this case, I have to be more specific. So what it did is it created a pending task in my task queue. And in order to play the rules of the game like exactly the way they're written, you actually have the right to do a lot of these things in any order you want. So they usually basically all go onto your task queue. I think maybe that might be yellow mode. No, that's not yellow mode. What it is probably auto off. Yes, you can turn off auto execute. Then you're like really have the permission to do anything the game lets you do, but it's a pain in the butt. So I usually keep it on. And I have a task now. The task tells me what the abstract instruction is, and it tells me why it didn't execute. It says here, it's abstract. I can't highlight things. Why can't I highlight? There we go. It tells me that it's abstract. So now I can say, let me look at my map again. I can say task A, and then I can refine that abstract type to a concrete type and say city tile. I don't have to say player one because it knows I'm player one. Land, and then I get to pick a land area that doesn't have any neighbor. So let's pick 3, 3. Okay. That would be Tharsis 3, 3. I also have abbreviations for everything. I can actually, do it like that if I want to. I try to avoid it because the language is cryptic enough as it is, and people will find this hard enough to understand as it is. But I told it what I wanted to do more specifically. It still credits Research Outpost as the thing that gave it to me, which it should. I didn't do it manually. I just clarified it manually. And now my task queue is empty like it should be. So there's a lot of different things I could do. Oh, I know a thing we could do. Here's our board. There is at all times a phase object that exists in the game state. One instance of phase, and right now it's corporation phase, just because things start out that way. I could exec action phase from corporation phase. If I want to, it changes the phase, changes my prompt here. In some ways, the phase is just a component, just like a greenery tile or anything else. But then, some things are programmed to key off of that. In any case, let's look at my board, and then let's exec production phase. This will be fun. All that stuff happened. You can pause and look through that stuff if you want, but point is, instead of having just 656 money, I'm going to have 661. I'm going to have 4 steel and 14 plants. And there you go. So production phase works. There's some stuff. If you look at this really closely, you'll see things called gross hack and stuff like that. So don't look that closely. Squint at it a little. If you squint, then hacks will be invisible to you. There are definitely hacks in this thing. I make no bones about it. In order to get this to work, I have to hack things all over the place. And then just as time goes on, I try to clean up some of the hacks while I'm making some of the other ones. When I executed the production phase, there's some triggered effects in there that cause it to do all this stuff. And then the engine realizes that the production phase is done. It knows that there's nothing else waiting to happen. And so it proceeds. It automatically triggers the research phase, which causes a generation to be added. I don't know why these things appear out of order. And the order is not necessarily significant. This money came from my Terraform rating during the production phase. Don't worry about that. The point is that the research phase put these pending tasks on the queue that we have to resolve. Here's a bug. The bug is that they're both owned by player one. They shouldn't both be owned by player one. That just happened because I was player one when I kicked it off. But really, the engine should have owned them, and the engine should have assigned them to the player in question. Right now, who owns the task doesn't matter that much because I'm the only one sitting here doing stuff. This part is the more important part, and it's correct because that is who the things are going to go to. The reason it couldn't execute this command is that it has a question mark at the end of it, representing the fact that it is one of these optional instructions. When you have 4 of an optional thing, that means you can choose any amount from 0 up to 4. And so if we decide to complete task A by doing 3 by card, it will allow that because that I'm choosing a value for that optional 4, and then it will take away the 9 money and give me the 3 project cards. And it doesn't have to worry about which project cards they are. It doesn't have to worry about a draft phase or any of that stuff. One day we'll get to dealing with all that, but it's nice to not have to worry about it right now. So of course, as player 2, I would also have to do some stuff. One thing is there's no such thing as a gain or lose instruction with the amount of 0. 0 is an invalid instruction. But when there's an optional thing, like you can optionally buy up to 4 cards, you can replace that with the null instruction, which I decided to name OK. Task B, OK means everything's fine. I don't need to do anything. No state changes. Let's look at the log. The log, by the way, you notice that a lot of numbers are skipped. That is because if you are certifiably insane, you can say log full, and you see every little change that happened to the task queue, every system. There's all these system components that are needed to make stuff work. It's a real mess, but that's why the number, that I'm up to is already 514, even though we obviously didn't do nearly that many things. I think I'm going to kind of leave it there. Let me check for other things I wanted to. Oh, of course, blue mode. How could I forget blue mode? Blue mode's very important. All right, in blue mode, here we're no longer in the sandbox where we can do whatever we want. All we can do is say, hey, I would like to have a turn now. And in order to make this work, I'm going to, as engine, declare that it's the action phase. I hope this works. Didn't like that. As engine exec action phase. So now we're in the action phase. If I asked the engine, please give me a turn, but we were in the research phase, it would be like, huh? What do you mean? I don't know. But now I can do it. I can say, give me a turn, please. And what does it do? It puts something on my task queue. It puts an abstract type on my task queue that says I'm going to use an action. It's going to be me, and it's going to be some standard action, but I don't know which one yet. And it's actually optional to do it because if I don't do it, that means I pass. So I need to replace that abstract type with something concrete. And if you didn't figure this out, when we have these generic types with all these different dependencies expressed in there, the type is only considered concrete if all the classes making it up are concrete. So even though player 1 is concrete and use action is not concrete, I have to refine them both. Let me explain this a piece at a time. First, let me list standard action. These are the choices for what I have for refining or specializing the standard action. I'm going to perform the task and I'm going to tell it how I want to narrow it down. It's still going to be for me, but I'm going to choose which standard action. I'm replacing a more general abstract type in our generic type system with a more specific one. And let's say we want it to be, I think we have a lot of plants, right? So I think convert plants is going to work. And now this won't work for the reason that use action 1 is itself abstract. Some of the things that you use actions from have multiple actions. And as a result, there are different types called use action 1 and use action 2. And probably use action 3, although I don't think any published card actually has 3 actions on it. This worked. It happens that all the standard actions only have 1 action on them, but whatever. I went ahead and set it precisely anyway. I made a concrete type, it did it, and now it's replaced my task with a different task. It knows that I need to remove 8 plants that belong to me, and it knows that I'm going to get a greenery tile, but it doesn't know where I want to put it. Now here's more of this gibberish, right? A land area that has a neighbor, which is an owned tile of mine. That is how greenery tiles work. There is a pending issue that I filed where it needs to figure out how to provide for the possibility that you have no legal spaces to play. In that case, it's supposed to let you play anywhere. This does not let you do that, but I'll fix it one day. I think I have hit a bug here because I think that owner should have been replaced with player 1 at this point. That is kind of boring, so I'm just going to drop the task and forget that I did it. That didn't work. Maybe it's task B drop. Yeah, that worked. Let me just look at the task. Sorry. Help task. It wasn't super clear. Okay, I need to improve that help task. I need to explain that I can also say task B drop. I'll try to remember to do that. So the deal with blue mode is that all I can do is ask for a turn. It puts a very generic thing on my queue, and then I start revising that to be the more specific version of itself. I execute that. That might trigger other things to go on my queue. I refine those things. That might trigger other things. When my whole queue is empty, then I can do other stuff. I could ask for another turn. It'll still, it'll let player 1 just ask for 8 turns in a row if you want. The only time when there will actually be game integrity, where you'll be prevented from actually making a bad state, is when I implement, or when we implement, because you're going to get interested in this and help out. When we implement purple mode will do all of the orchestrating of the overall workflow of the entire game. Blue mode just lets you take individual turns. And the thing is not smart. I can say I don't mean it's not smart. I just mean it's very permissive. I can say, let's go back to the corporation phase. This might work. It did. And now in my blue mode, and I'm still player. Oh, wow. I have another bug. Okay, I see. The bug is the other phase. You know what? I did it badly. There's this issue right now where I have to make sure that whenever I create a phase, I have to remove the old phase myself. I have to tell it which phase to delete at the same time as it's creating. I need to go into green mode to do it. Let's go back to blue mode. Okay, now we're okay. Now we have only one phase in effect. There's an issue filed about this stuff. Phases should be constrained so that you always have exactly one at a time, but it's not working. All right, we're back in blue mode. And all that I wanted to show now is that now when I ask for a turn, it does something different because of the phase. It lets me play any card front I want. I really ought to play a corporation card, but it doesn't know. Obviously, if I'm playing a real game, I will be playing a corporation card, and then I'll log it here. And then I have up to 10 buy card thingies that I can do. That's probably enough. Now, maybe I could show you a little bit of what's going on in the code. I know this video has gotten long, but hey, you can always pause it if you want to. Here is how some of these things are defined. This is another aspect of the pets language. I've shown you a lot of the one-liner pets things that you can do, triggered effects and stuff, but all these class names that we're using are defined using a different pets syntax. And what's something interesting in here? Let's go to resources. In pets, you can make subtypes just by nesting. It's very convenient. You have an abstract thing called resource. You nest inside it standard resource, and that automatically makes it a subtype of resource. That's nice because if you remember that picture of the whole component model, it's very deep. We would be, repeating stuff all over the place. So this is really handy. We've got mega credits. For some reason, I made a common super type of steel and titanium called metal. I think that's because I'm experimenting with different ways of making mining rights work. I might not stick with that. And then the remaining standard resources are plant, energy, and heat. And you'll notice that energy has a bit of behavior. Its behavior is when it sees that a production phase is happening, it creates one heat from itself. From means, delete the thing in the process of creating the other one. Transmute directly from an energy to a heat. And that actually works. You saw it work when we were using the thing. Production is I'm not going to talk about production. It's very magical. Very magical. One really surprising thing about how this works is that card backs and card fronts are two completely different things in the game. It does not think of them as being different aspects of the same object, and that seems really weird. But if you think about it, it treats city tiles and greenery tiles as being two completely different things as well. And in the physical game, they are two sides of the same thing. So it's not actually that unprecedented. Whenever you play a card from your hand, you're just transmuting a card back into a card front, but they're two different things. In here, we can have some constraints. Has max one this means if there's an instance of Arctic algae of player one, there cannot be a second instance of Arctic algae of player one. We would like to go further than that. We'd also like to say there can be no instance of Arctic algae by any player. There's just one total. I don't remember whether we have that working yet, but this doesn't do it. Here's a weird thing where creating an event card puts a task onto your queue to change that event card into a played event. But it puts it on your queue, so it lets you wait to flip it over until the end of the turn. What else is in here that's interesting? Here's all our tags. I created, types called biotag and planet tag because those are really helpful for when we get to turmoil. But they're not strictly a game concept, just a convenience. Card resources are a little strange and a little tough to understand. I won't go into them right now. An action used marker. This gets placed on an action card when you take the action. Because it goes on a card, it is card bound. And card bound means it depends on a card. Well, what kind of card? Well, it has to be an action card. And that's how you can express that. You can say it's a card bound that depends not on just any card, but on an action card specifically. And it's also generational. What is generational? Where did I put that? It's just a simple little base type. Where is that thing? You know what? I'm going to use this advanced search feature. All right, all generational is this thing right here that says when there's a research phase, I delete myself. That's it. No big deal. So anything like, that doesn't survive from one generation to the next, I can just make it extend generational. All the payment mechanics are really nasty. I'm not going to go into that stuff. There's gross hack at the bottom. Don't look at it. Don't look at the gross hack. It's terrible. Other things worth showing. There's a lot of gobbledygook here. Here's where it says when you try to play a building tag, that authorizes you to spend steel on it. Why this is the syntax for doing it will take a while for me to explain, but that's where that game rule is represented. And basically every, rule in the game gets represented in this pet syntax in one and only one place. Maybe not every, but that's the aspiration, and it's pretty close to it. There's one way to represent that when you create a temperature step, if you made there be exactly 3 of them, that means that you get a production of heat. How nice is that? That works. I didn't show it, but it works. Well, let's show it actually. Why don't we? Let me go back to green mode. Nope, that's not how you go back to green mode. Let's count our temperature steps that we already have. Let us create one. Let's create 2. And the really weird thing that will happen is that the engine knows to atomize the instruction. That is, it knows to separate them into one temperature step and then another temperature step. And that is important because if it didn't do that, when I do this again and I make the temperature step count reach 4, it would not trigger the heat production bonus. So by splitting it up like that, then one of them can trigger the heat production and the other one doesn't. The way it knows to do that is just that I made global parameter extend this type called atomized. And then I'll some other time get into how that works. I mentioned that there are quantifiers on commands like question mark means optional, exclamation point means mandatory. There's another one that is the period, because that seems like the punctuation that's kind of between exclamation mark and question mark, so I called it period. It means you must do it as much as possible, but if you can't do the whole thing, that's fine. And so I made global parameters default to using that quantifier. Any global parameter that you try to create will automatically get this quantifier that says gains and removes are if possible only. And as you might have seen or you might have guessed, card resources have the same thing. If we find card resource, where's card resource? There's a default quantifier of period. You gain them if you can, and it's okay if you can't. So that's kind of cool, I guess. Here's where all the areas are defined, Mars areas, land areas, etc. I think I'm ready to wrap up this initial video. I didn't really plan any kind of closing, but I guess I can just riff for a minute on what's going on here. I'm basically like just now making the project public. It's on GitHub. You can, I don't know, I'll put the link in the YouTube description or something. You are more than welcome to file issues to it or to email me at this address or really contact me any old way you feel like if you find all this interesting and you think that you might want to help with it. I have been doing all this by myself. I've been working on this for about 2.5 years. It took that long to get it to the point that it's at right now because I basically have no idea what I'm doing. So all of this was extremely difficult for me to figure out, and I'd love help. There's going to be a Discord link. The Discord is really not used at all yet, but I'm hoping that, some people will show up and will start to use it. And at this point, I will just sign off and say thanks for listening. And I'll see you in either email or Discord or any other mechanism you want to use. Bye.